Today we're going to be looking at 2.6, ratios, rates, and conversions. Before we get started, we have some vocabulary, so if you need to pause the video, go ahead and do that. So a ratio compares two numbers by division. A rate is a ratio that compares quantities measured in different units. A unit rate is a rate with a denominator of 1. A conversion rate is a ratio of two equivalent measured in different units. And unit analysis is using units in conversion problems to determine units for answers. So let's just look at some examples. Example 1, we're comparing unit rates. So A says you are shopping for t-shirts. Which store offers the best deal? So we have store A, store B, and store C. Well, if I want to know which store offers the best deal, I want to figure out how much it costs for one t-shirt. So I find a unit rate. If store A costs $25 for two shirts, I'm going to do 25 divided by 2. So I get that answer, and 25 divided by 2 is 12.5. So it costs $12.50 for each shirt. So store B is $45 for 4 shirts, so I take 45 divided by 4, and when I do that, I get 11.25. So far it's cheaper to go to store B because it's less money. It only costs $11.25 per shirt. Store A costs $12.50 per shirt. Store C is $30 for 3 shirts, so I'm going to take 30 divided by 3. Well, 30 divided by 3 is 10. So it's only $10 per shirt at store C. So store C offers the best deal because it's cheaper per shirt. So then B says if the store B lowers its price to $42 for 4 shirts, does the solution to problem A change? Well, let's check. I'm doing 42 divided by 4. Well, 42 divided by 4 is 10.5, or $10.50. So that does get better, but it's still not as good as store C, who charges $10 per shirt. So does the solution to problem A change? No. So that's an example of a unit rate. Now we're going to look at conversion rates. Now, I gave you a conversion chart, okay? So we're going to use that to help us. So example A says 330 minutes to hours. If I look at my conversion chart, I know that 1 hour is equivalent to 60 minutes. So we're going to use ratios to do all of this, okay? Or rates, I should say. So I'm going to start using 330 minutes. So 330 minutes. I'm going to make this into a fraction just to make it easier for us. Since I want to convert minutes into hours, I am going to multiply my fraction by the conversion rate. Since I want to go from minutes to hours, okay, I'm going to use this conversion rate and put it in fraction form. The hours are going to go on top. The minutes go on the bottom. So from there, I'm just multiplying across. I'm taking 330 times 1, which is 330, 1 times 60, which is 60, and then I actually divide these two. Now when I divide them, I want to get the decimal, not the fraction. So if I divide 330 divided by 60, I get 5.5, and it's hours. Now we can use unit analysis to help us make sure we did this correctly. If I look at example A, I wrote out my units. Well, just like a fraction, if I had 2 on the top, 2 on the bottom, they would cancel the 1. If I have a unit on the top of my fraction and a unit on the bottom, they cancel out. So the only unit left is hours, and that's what I was trying to convert it to. So let's try example B. So what you need to know for example B is that 15 going from kilograms to grams, 1,000 grams equals 1 kilogram. So I'm starting with 15 kilograms. So I'm going to write that out. 15 kilograms. And I'm going to make that into a fraction, so I put it over 1. And I'm multiplying it by another fraction. So I use my conversion rate. I just found out that 1,000 grams equals 1 kilogram from my conversion chart. I'm going to write that as a fraction. Since I want to go to grams, that's what goes on the top of my fraction. It's 1,000 grams, and on the bottom would be 1 kilogram. Now I'm just multiplying across. I'm taking 15 times 1,000, which is 15,000. I'm taking 1 times 1, which is still 1. And 15,000 divided by 1 is 15,000. Now, if I look at my units, I wanted to go from kilograms to grams. Well, using unit analysis, kilograms on top, kilograms on the bottom cancel out. So yes, I'm left with grams. So my answer is 15,000 grams. All right, let's look at C. See, I have 5 feet 3 inches to inches. Well, part of this is already in inches. It says 3 inches. So I'm not going to worry about that. I'm going to try to convert the 5 feet into inches. So I start with what I'm trying to convert. So I put 5 feet and I make it over 1. I know from my conversion chart that 12 inches is 1 foot. So that's what I'm going to use for my next fraction. Since I want to go to inches, the 12 will go on top. The 1 foot goes on bottom. Now I'm just multiplying across. 5 times 12 is 60. 1 times 1 is 1. 60 divided by 1 is 60. And again, if I look, the feet cancel out because there's 1 on the top, 1 on the bottom, and I'm left with inches, so I have my units. Now, the original problem was 5 foot 3 inches. So 3 inches, it was already converted, so I didn't use that. So my answer isn't 60 inches, it's actually 63 inches. All right, so last example here, 1,250 centimeters to meters. If I use this one, I'm going to start again with 1,250 centimeters, and I put it over 1. The conversion for centimeters to meters is that 100 centimeters is in 1 meter. So since I want to go from centimeters to meters, the meters would go on top of my fraction, the centimeters would go on the bottom. Now I'm multiplying across. So 1,250 times 1 is 1,250. 1 times 100 is 100. And now I divide the two. So 1,250 divided by 100 is 1.25. So my units, the centimeters cancel, 1 on the top, 1 on the bottom, and I'm just left with meters. So my answer is 1.25 meters. Now that was how you convert one unit to another. We also need to know how to convert a rate. So if we notice example A, it says a car is traveling 55 miles per hour. What is the car's speed in feet per second? This is different because our original problem has 2 units because it's a rate. It's 55 miles per 1 hour. So when I write my fraction, I have 55 miles per 1 hour. Now I'm trying to go from 55 miles per hour to feet per second. So I have two different things that I need to do. I need to go in the numerator at the top, I need to convert that from miles to feet, and in the bottom I need to convert that from hours to seconds. So I need a couple conversions. One, I need to know that 1 mile equals 5,280 feet. I also need to know that 1 hour equals 3,600 seconds. So, I am going to start with my first fraction. I'm going to change the miles to feet, so I'm working with the top right now. I'm using this fraction, because that's what I'm converting, miles to feet. Since I want to go to feet, I put 5,280 feet in the top, or on the top, 1 mile on the bottom. Now I'm not done because I've changed miles to feet, but I have not changed hours to seconds. So I need another fraction. Now this one in the denominator, I'm trying to change it from hours to seconds. So this conversion right here that we're using, I am going to put the 3,600 in the denominator because I want the bottom to turn out to be seconds. The 1 hour would go on the top. So now I'm just multiplying my fractions across. I'm taking 55 times 5,280, which is 290,400. I'm in the bottom, I'm taking 1 times 3,600, which is 3,600. And then I'm dividing the two. So when I divide that, I get about 80.67, and my units would be feet per second. Now I can check that by using unit analysis. The miles cancel because I have one on the top, one on the bottom. The hours canceled, I have one on the top, one on the bottom. All I'm left with on the top is feet, the bottom is second, hence feet per second. So let's look at B. It says convert 75 cents per hour to dollars per day. So the conversion that I need here is that 100 cents equals $1, and I'm going to use the dollar sign. I also need to know that 24 hours equals 1 day. So I'm going to set up my conversion. I have 75 cents per hour, so per 1 hour. In the numerator, I want to change cents to dollars because that's dollars per day. So in this conversion, since I want the top to go from cents to dollars, the dollar would go on the top, the cents would go on the bottom. Now, my next fraction, I'm changing hours to days. Since I want to go from hours to days in the denominator, the 1 day would go in the denominator, the 24 hours would go in the numerator. And again, I can check to see if I did this right by canceling my units out. The cents cancel, and the hours cancel, so I'm left with dollars per day. So I'm going to multiply 75 times 1 times 24, which is 1,800. I'm going to multiply 1 times 100 times 1, which is 100. And then I go ahead and I divide that. So 1,800 divided by 100 is $18 per day. So a couple more. If I look at C, it says convert 2 quarts per minute to gallons per second. So what I need to know for this one is that 4 quarts is in 1 gallon. I also need to know that 60 seconds is 1 minute. So, if I look at C, I start with 2 quarts per minute. So I'm going to go, and I have 2 quarts per 1 minute. On the top, I'm trying to change the quarts to gallons. I have the conversion rate right here. It's 4 quarts equals 1 gallon. Since in the numerator I want to go from quarts to gallons, I put 1 gallon on the top, 4 quarts on the bottom. Now in the denominator, I'm trying to go from minutes to seconds. So in the denominator, I would have 60 seconds on the bottom, 1 minute on the top. Now I go ahead and I multiply across. 2 times 1 times 1 is 2. 1 times 4 times 60 is 240. If I divide this through, I get a really small number. That's okay. 2 divided by 240 is about 0.008. And that would be in gallons per second. If I want to check to make sure I got my units right, I cross out quarts on the top, quarts on the bottom, minutes on the top, minutes on the bottom, and I'm left with gallons per second. So this is my answer. Now example D we're going to go over in class tomorrow. So we're done with the notes for today. If you had any trouble, you should go back and rewatch this video and make sure you list on the Google form that you're going to fill out below what you are having trouble with. I'll see you guys tomorrow.